In this video, we will see how is done cooling and dehumidification of the air by air conditioners type split with a unit exterior and with one or more several indoor units. We will see how is done cooling and dehumidification of the air inside the indoor unit that mounted on the wall of the building interior. We will see the component parts of the indoor unit, and we will describe the physical phenomena that lead to the cooling and dehumidification. We will see the source of interior humidity, the link between the number of people in the building, and the ratio between energy consumption for cooling and dehumidification. We will see the heat flow release at dehumidification, the formula. We will see the calculations for cooling period and energy required for cooling, and calculation of the energy required for dehumidification. Let's see now how air conditioners type split with a unit exterior and with one or more several indoor units works. The outdoor unit is the one that provides coolant that sends him to the inner unit. In the indoor unit, cooling is happening and dehumidification inner. The people release humidity by breathing and sweating. Also, humidity can be generated in bathrooms and kitchens. The humidity rises with the hot air, enters in the interior unit where it's condensed and also is cooled. More about outdoor units, see the video in the description. For energy auditors or the people interested by energy performance of building, in this video description, you will find a link to a website about energy performance of buildings or a link to a video more simple for the population. Let's see now what's happening inside the interior unit. The indoor hot air loaded with water vapor enters in the indoor unit, reaches on the cooling condensing element, where air cooling leads to condensation of water vapor, goes to rotary motor air blower, which returns to 180 degrees the airflow, additional air cooling by cooling on condensing element, and after that the airflow is exhausted through air swing panel. The condensation of water vapor from the indoor air, it calls dehumidification. By dehumidification, we mean the total elimination of water vapor emitted inside by the occupants of the building directly or through their occupations. Let's see what's happening into the inside unit. So, indoor hot air loaded with water vapor enter and meets an element cooled, which produces the condensate air and appears water. The energy from the condense is taken from this element, from coolant from outdoor units, and it goes to coolant to outdoor unit again to retake the energy. The cooled air with less vapor takes outside. The heat flow released by dehumidification has this formula: the number of average people in the building, or humidity release per people, or latent heat vaporization of water, or 1 minus Na. Number Na is number of air changes per hour. We multiply by 1 minus Na because the air that enters from the outside, it completely eliminates the humidity release in the building proportionally. For example, for Na equal 1, there's no more condensate moisture. Everything was eliminated with the stale air that was completely replaced in an hour with the air coming from the outside. Let's see more detailed the components of interior unit. We have dust filters. We have cooling and condensing element seen from the front. Also, we see the same element from the back, from the wall. Let's see now again what's happening on it. So indoor hot air charged with water vapor enters in the top of this element. After that, it it takes the condensation and appears water vapors and appears droplets of water vapor. After that, the cylindrical ventilator rotates with 180 degrees the flow of the air. Again, in the lower part of this element takes again another cooling and cooled air with even more light water vapor. And here are condensed water droplets vapor. What does the phenomenon of water vapor condensation mean? When we take out a bottle of cold water from the refrigerator, on its surface appear drops water vapor condensation from the air. Dew point. What does it mean, dew points? Is the temperature from which condensation begins, vapor condensation of water in the air. It depends on interior temperature of the air, and also it depends on relative humidity of the air. More about condensation, see the video in the descriptions. Sources of humidity for a house are breathing and sweating, approximately 60%, which means 56 grams on hour per person. Bathroom, 22%, which means 22 grams on hour and person. And kitchen, 18%, which means 18 grams on hour and person. The total 100% is 96 grams on hour and person. The amount of condensed water from vapor is proportional to the number of people in the cooled area. This is the water vapor, condensed water vapor from the outside of the building. That means if we double the number of people in the house, we'll double the amount of condensed water from vapor. Proportions of energy consumptions between cooling and dehumidification. It varies between 19 and 10% to 60 to 40%. The proportions vary depending on type of building, if it is residential or non-residential. The degree of shading of the building, the more shaded the building is, the higher the proportion for dehumidification. For calculating the energy needed for cooling and dehumidification, first we will calculate the cooling period of time. More details about those calculations are explained in the video of application in IntelliEPB, which is in the website from the description of this video. Once we have the period for cooling, we can use those monthly calculations we transform the fluxes from solar from windows, from opaque elements, from internal flux. Monthly, we have those calculations about energy, and the sum of all those energy is the energy for the cooling season. Very important is the shading reduction factor for the windows, which can be taken from this table B21, from this standard. And the most important one is for aluminum coated textiles for exterior blind, which is 008, and we will see what is the effect of this one, this shading. So the period for this period of cooling and the energy requirement decreased very much. Now let's put our initial shadow, that it means 1, that it means no shadowing. Let's see now how we make calculation for dehumidification. We have the formula presented in front, which is depending on the number of weighted average number of person, occupation rate, water vapor release per person, the latent heat water vaporization, and or 1 minus Na, where Na is number of changes, air changes per hour. The house we look for those calculation is a medium house with a medium insulation. Is situated in Bucharest, Romania. We have a weighted average number of person of 4, let's say one person at 25 square meters. We have an occupancy rate per month of 1, so that means the house is all time occupied. We have a water vapor release, and we'll see after that what's about that. The latent heat vaporization, and for every month in the period of cooling, we have those sums, and the total sum is the energy necessary for all the period of cooling for dehumidification. Where we can get the water vapor releases per person. There are a number of sources of information. Those information are for different types of buildings. We will look exactly at the individual home. We have also humidity generated for cooking and bathroom. We will make a total, and that total for an individual home in our case, we'll put it here. We see that the energy 319 from the total 1500, it's approximately 20%. And let's see what's happening again when we have a maximum shadowing 0.08. We see that the amount, the ratio of dehumidification from the total cooling and dehumidification is approximately 40%. Always in the energy performance certificate at this cooling section appears the sum of cooling and dehumidification.